This is an example program that I wrote to work with logic, combinational logic, AND gates, OR gates, and things like that. It ends up that these are very simple things to convert to ladder logic. I've also posted these example programs in the portal on the course so that you can download them and run them and try them. But it was a way to get people who are starting to use the HMI interface to get used to some very simple ladder logic programs that are used very often, and also to become familiar with the memory allocation and use of different memory bits and other different sizes of variables and things like that in the program. So this is the ladder logic program itself. You can see each section is labeled. Here's an AND gate, and then here's the implementation of a 2-input AND gate. And as I scroll down here, here is an OR gate. Here is a NOT gate. And here's an AND gate. And there's two different ways to implement this. This method that I used here takes an output and refers to it with an input. There's probably an easier way to do that, or there definitely is an easier way. At this point, I wanted to show you how to connect outputs and that you can refer to them with input instructions also. There's an OR gate, and then there's an exclusive OR and exclusive NOR gate implementations that use our knowledge of logic, of Boolean equations, and be able to write those. So we're going to take a look at those. I've also have 3 different displays here. Maybe I can scroll this down a little bit and we can see more of the screen at the one time. The displays allow me to hit buttons. Now, I had to be careful how I implemented these, because if I made them momentary buttons, I couldn't push 2 of them at the same time. So I made them toggle switches, and we'll take a look at that very quickly. If you go in here, you'll see you'll just hit the toggle for that operation. So that's one thing that's just a little bit tricky as I was going along. Also, too, you'll see these instructions down at the bottom of the screen. I used the buttons at the bottom of our V350 enhanced PLC, the F1, F2, F3 buttons, to switch between these screens. So this program also includes multiple HMI screens. Here's the second one, which shows you the NAND gate and the NOR gate implementations and let you run them. And here's the third one, which does the exclusive OR and exclusive NOR. Now, the main routine has all the code, and that code is running at all the times. What you need to do is switch between the HMI displays if you want to, exercise the other part, but the code is sitting in the back running all the time. Okay, that gives you a quick introduction. Let me move this back up just a little bit more so that we can look at the operands in memory. You can see this is a very simple program, so we're using a lot of memory bits, and in the descriptions I tried to make them so that it would be easy to follow the program. So there's AND input 1 and input 2 and output, and you can see the corresponding memory bits for those. Same way with the OR gate, the NOT gate, the NAND gate, the NOR, and the exclusive NOR. So we used 22 memory bit locations to do this program. You also notice that some of these have I set up power up values so that they're zeros, and I'm learning too, so we did that. So let's download this program and let's run it, and we'll bring up the screen and see what happens. So once again, make sure your communications is set up first. I've been using my PLC for quite some time. Make sure your PLC is powered on, and make sure you have the USB cable connected to your PC and you've chosen the correct COM port. So I did that. I'm going to download this program, and hopefully you've done this a number of times. You're starting to get used to it. But as we do different assignments, you'll definitely gather that experience quickly. And I'm going to go through these windows. It's going to take a little bit of time. Once we get this up, we'll bring the screen up on the main display, the PLC screen, so that you can see what's happening at the same time I'm doing this. But it is going to take us a little bit of time to get this here, and things sort of lock up because the windows won't let me move around and do different things. But this is a great place to start because electronic technicians know logic very well. We don't have to hook anything up to the inputs and the outputs. We can get familiar with the ladder logic instructions, the most used, the simplest ladder logic instructions, and we can get familiar with the HMI display at the same time. So it made it over there. It's coming up on my screen. Notice that when it comes up on my screen, it's going to come up in this startup display with an asterisk. I can change the name of this, but for now I let it to emphasize that this is the one that comes up automatically on startup. And even if I do rename it, I'll probably leave the asterisk in there just to emphasize that that's the one there. So I'm going to hit this online test button. It's going to bring up this online mode, and I'm also going to show the screen, right? This is go to the current HMI display, or this shows exactly what's happening on the screen at the same time. So the nice thing is I'm running this, and it does give me some troubleshooting ability. I might also want to look into the operands that I have and see what's happening. And I think if I move my screen over here a little bit, we can maybe do both those things at the same time. The screen that you see on your PC is only for development. It doesn't have any troubleshooting thing. It doesn't change while the program is running. So this Vision 350 screen is pretty nice because I don't have to hold the camera up or have two cameras to show you what's going on. So we have an AND gate, right? And we know the truth table for an AND gate. So if I press one input of the AND gate and make it a 1, the output's still a 0. If I press the second input of the AND gate, make it a 1, the output's a 1. If I turn this one off, you can see it's back to 0, and if I put both of them on, it's a 1. And we can go through the whole truth table in counting order if we want to. We can do the same thing for the OR gate, and it does the OR function. Hopefully it does, because I think I tested this program out. And we can do the same thing for the NOT gate and see what's here. But if we want to do the other screens, or we want to test the other gates, we have to change the screen. And you'll see the note at the bottom of the screen here that tells us F1, F2, and F3 will change those screens. So I'm going to press the F2 button on my Unitronics V350, and you'll notice it changes over to the NAND screen. Took a little bit of delay until it comes up on the screen that I'm showing you, the remote screen, but it's responded, and we can turn around and press the buttons and test all those functions out until you go. And see what's there. And once again, I'm pretty sure I tested this right. I think I got the logic correct. And let's hit the F3 button to go to the very last screen. And these are exclusive OR and exclusive NOR gates. And it's nice. I think things work. I would probably look at the example program to see how to go back and forth between the screens. So I'm going to close this and get out of this remote mode. I think this will do what I want. So I'm going to get out of there, and I'm going to hit the eyeglasses again to get out of there. That's how you leave the remote mode and go back to your VisiLogic software to do some development. I'm going to drag the variables down here a little bit, and let's look at the main routine code in just a little bit more detail. AND function, pretty easy, right? This instruction and this instruction, they both have to be a 1 for the output to become a 1. And that's pretty simple. So when you want an AND function in ladder logic, you put stuff in series. And the stuff that you're putting in series is this instruction here, which is called a direct contact instruction. 2 of those, and to represent our output, this is a direct coil. And then all of these are associated with the memory locations listed up here. Make sense? I think that should be good. Here's an OR gate. And obviously things are going to be in parallel. So this input goes high. That's going to make this output location store a 1 or turn the bit that we have this associated with is going to store a 1. Or this one, or both of them. Okay, you can implement this OR gate 2 different ways. I chose to make a parallel connection for this instruction, but you also can put this instruction right over against the left-hand side so that both of these are there. It'll work the same way. Okay, a NOT is very interesting. Instead of the direct contact instruction, I put an inverted contact instruction in there. So if this is remember, as I probably explained this before, but I think is easy to remember, this what shows up on the screen when you place an instruction is what's going to happen when a 0 is stored in the corresponding location that you associate with that. So when there's a 0 in this location, this is already going to have continuity across here, and a 0 in this location is going to give you a 1 in the output. When you have a 1 in the associated memory location, this is going to go to the opposite state. This is going to open up, and there's not going to be continuity here, and that's going to make a 0 store in this output. Some students have a hard time doing that. I'd say just separate the two. Think of the instruction as it sits on the screen is what happens when the associated memory location is a 0. So you unattach both those two things, and I think it's pretty easy to understand. NAND gate. The way that I did a NAND gate here is an AND gate, and then I took the bit for the output instruction. This is an AND function here, and I fed it down to this next line. So these two instructions, this is an output instruction, a direct coil, and this is an input instruction, an inverted coil, or contact, I'm sorry. And whatever this is, this inverts it, and then this is the output of an AND gate, or I'm sorry, the NAND gate. So this is just an intermediate storage location where I get an AND function and then invert it. And that's one way to implement an inverted output instruction. There's another way to do that, and I'm going to show you that down here when we get to the NOR gate. And this NOR gate implementation is done 2 separate ways. Only one of them is put up on the HMI interface. But if you look, here is the OR function being implemented, and then here is the intermediate OR location output, which is fed associated with down here. So I connected these two things together. This sort of freaks some people out. They see an output instruction, and then the bit that stores for the output instruction is then used to be associated with an input instruction, but that's a very valid thing to do. And then this output will give you a NOR function. This shows it done directly, implementing the NOR by, instead of using the direct coil output, it uses a NOT of the direct coil. And you might have a hard time finding that. It's not on one of the common used instructions. And then there's 2 ways to deal with that. If you right click on here and you replace ladder element, you can change this right as it sits in here. So some people always place a direct coil instruction and go right in here and change it to an inverted coil. If you want to do it directly, you can come up here to the Boolean pull down, come to coils, and pick your inverted coil instruction and drag it out. Okay, once again, uh, you can think of this the exact same way that you did before. You can think of it as an inversion, or you can think about how it sits here, and um, it's going to store a 1 when it doesn't have continuity on the rung, and as soon as you get a continuity on the rung, it's going to store a 0. Okay, very similar to the direct contact and the inverted contact input instructions. The last part that I want to take a look at in the program here, the code, is the code for the exclusive OR and the exclusive NOR. And we know the Boolean equations for these. We know that we can just create a truth table, and from that truth table find the rows in the truth table where the output is a 1, and then create the logic function for those and OR them together to get that. So it looks like the logic function for an exclusive OR is the A input whenever the A input is low and the B input is, or I'm sorry, whenever the A input is high and the B input is low, or when the A input is low and the B input is high. That's the logic function for that. And all I have to do is implement that in ladder logic. So I can take my Boolean equations and transfer them right into these programs very easily and create some complex combinational logic and implement it very fast. Someone who's not trained in electronics might have a hard time doing that. It should be a direct translation for us, no matter how hard or how complex the Boolean equation is that we want to implement. So we've done that for an exclusive OR gate and an exclusive NOR gate, and you should be able to translate that through. And we're going to make an assignment to create a program to do this. By the way, when we come over here in the HMI interface, we did some different things. Like we created some shapes on the screen. And the shapes don't do anything functionally, but they make things easier to understand. So I made a block and I put text inside that block. That's part of dropping that in there. When you play with these shapes, these rectangles, it lets you put text in there. And then I made 2 lines for the inputs and 1 line for the output. Okay, there's nothing active about these. These are just shapes that enhance the user experience, make it easier for them to understand what we do. As far as the inputs and the outputs go, if I double click on this, this says it's variable binary text. And you'll be able to find that over here. When I have this window closed, if I come over here, binary image or switch, up here is text, right? And here's binary text and switch and a list of things. So you should be able to experiment a little bit and find out which of these interface elements I've added. There's not a whole lot of interface elements over here for creating your HMI screen, but it takes a little bit of time to get used to them. So each of these is a variable binary text thing. I've chosen the toggle to make them toggle buttons. I just have text for a 0 or a 1. That's what shows up on the switch. And then I associate them with one of the inputs that I created, the specific input for each of the gates. Okay, this program is available to you. You'll be able to download this program very easily, load it into your thing, and play with these settings yourself. The output, if I double click on that, this is variable binary text. And once again, I chose to just display 0s and 1s rather than pictures. This obviously is not a toggle switch, it's an output that is either 0 or 1. And I tied it to the corresponding memory bit location for the NAND gate output in this case. So when I go through this program, all I do is create all the logic in ladder logic, and then I associate all the bits with this. And these links are easy to do. If you click on this, up comes this window that you're used to, and you click down here. As long as you keep descriptions for stuff, you shouldn't get yourself confused. You should be able to figure out how to associate them. And we'll do that in another video, but this one I just wanted to introduce you to some ideas for starting a program out with knowledge that you should be pretty familiar with, and it's useful. So if you have any questions, please ask. Otherwise, we'll keep on advancing you with different topics.